All right. Hi, everybody. Thanks for coming. Thanks for having me here. It's my first time in this side of Europe, and I've been enjoying a lot the conference today. Um, I have the task. I have the task of talking to you about microservices again. I'm really sorry about that. If I knew there would be so many presentations on microservices, I probably would have talked about something else. But I hope you can endure one more. Maybe I can't guarantee it's just one more. I don't know if next person is going to talk about. Anyway, I will not be talking about microservices again today, unless you get me drunk. So my name is Phil. Um, I'm originally from Brazil, but I live in Berlin, Germany. And this presentation is really about the work we've done at SoundCloud in migrating from what's a monolithic architecture, one might say, to microservices. I've given, and various different colleagues and friends of mine have given different talks and written articles and things about the work we've done at SoundCloud. It's a bit extensive because there's a lot of different parts to it. So I'll focus on one specific thing, which is retrospect of what now myself Phil thinks about some particular aspects of our journey to where SoundCloud is right now. So let me see if this is working. Yes. So of course I have to add a disclaimer. I actually do not work for SoundCloud anymore. As of last month, I left the company, and I have joined DigitalOcean and in New York City. I have accepted this before leaving SoundCloud, so this is all still based on SoundCloud. But I have to tell you that I do not speak for the company anymore. Most of what we've done there is public and it's open source one way or another. So yeah, I can talk about it at length. But if you want the SoundCloud opinion on something, I'm happy to refer you to somebody who's still there, one of my friends. And also, it's been actually 2 months since I left, so some of these might have changed. I kind of know it didn't, but I cannot guarantee. So I don't work so much that actually just today I spent most of my afternoon chasing my SoundCloud friends because this is the DigitalOcean computer and it doesn't have the font installed, so it actually looked like this. So I had a lot of fun trying to make this work, but I hope that all slides in this presentation still have some kind of good formatting to it, even though I don't have the SoundCloud set up on it anymore. But talking about SoundCloud, when I first joined SoundCloud 4 years ago, I used to go give talks in Europe and other parts of the world. And the first thing I had to do was to introduce SoundCloud heavily. Oftentimes, only people who were really into minimal techno would really know what SoundCloud is, or maybe have heard of it. Over the past 4 years, the company has grown a lot. Maybe you don't know what SoundCloud is, maybe you do, but I'm sure you have bumped into one of our embedded widgets everywhere across the internet. And just as a sample, SoundCloud is the largest audio archive in the world. We're just second to YouTube. And I'll keep saying we, even I don't work there anymore. Just don't find it weird. It's kind of when you break up a relationship, it's just say us, and you know how this works. Anyway, so SoundCloud has everything. We pride ourselves on having all sort of kind of music and artists and style. Everything from the sound of bats having sex, and I'm not kidding, to Skrillex. And I do think they do sound the same, but that's just my taste. I'm more of an indie rock kind of person. So SoundCloud, this is just an assorted sample of likes that I had. People have followed on SoundCloud maybe 1 year, 1.5 years ago. You see The Offspring, you see Brazilian stuff, you see Mother Jones, the magazine, Foo Fighters, Neil deGrasse Tyson. There's everything, The Guardian. There's a bit of everything in the platform. I definitely recommend you spend some time. Look, there's heaps of technical podcasts. If you know things like, sorry, The New Stack, which is this big website that's talking about these new ways of building applications, containers, and all this stuff. Their podcast is also hosted on SoundCloud. But that's all cool. I mean, I'm setting the scene, trying to make you understand the products a bit better. But it doesn't really tell the story in the technical side. There are two numbers that I'm still allowed to share because they're public from SoundCloud that kind of can give you maybe some perspective on how big the challenge is inside the company or to the company. SoundCloud, as opposed to something like Spotify, they do let anybody upload audio to the platform, right? It's like YouTube. More YouTube, less Netflix. What means that we have 11 hours of audio being processed every minute. This is probably 12 now, but this is from a while back. But it's still the official number, I guess. What that means is that, so when you talk about uploaded, it sounds like simple, right? You get a socket, you send some bytes, you save some file, NFS, whatever, done. The problem is that because we do a lot of processing with this audio file, we run fingerprinters, we run transcoders, we feed various different systems, recommendations, and whatnot with the data, the audio itself, and the metadata. This is a very, very, very lengthy pipeline that needs to be applied. And at this scale, you really need it to perform very well because the user does not care that your fingerprint is taking too long. And the user needs to make that sound available right now, immediately. And another number is the 300 million users per month. It's kind of people per month. It's roughly equivalent to uniques if you into web analytics. When I joined SoundCloud, we have 5 million users per month. When I left, we were on 300. So we grew a lot, and everything broke. We had a lot of interesting fun nights trying to make it work. But that's kind of the scale of the problem we're talking about here. When I first joined SoundCloud, we had about 20 people in the engineering team. When I left, we were 150, spread across Berlin, a little bit in San Francisco, and a fairly big office in New York as well. But Berlin is definitely, like if you're looking for something in Europe, I definitely recommend investigating moving to Berlin because it's an awesome place, and considering joining SoundCloud there. So going back to the theme, less about SoundCloud, more about what we've done. A lot's been written about microservices recently, right? Oops. Oh. A lot have been written about microservices, all kind of blogs, and I used to have a microservice Google search alert thing, and at some point I just turned it off because every day you would receive 100 new posts, articles, forums, whatever it is. And that's cool because finally this idea has been in our heads for so long, and some people doing one way, some people doing another way, and we're never able to elaborate and to kind of create some guidelines and talk about it. That's great. There's one particular article that I really enjoyed, which was written by Martin Fowler. I guess most of you know who this person is. Martin is chief scientist for ThoughtWorks. Disclaimer, I used to work for ThoughtWorks 5 years ago. And Martin has written lots and lots and lots of articles around this microservices thing. And other people from ThoughtWorks, Sam Newman, James Lewis, have also written a lot about it. But this particular article, to me, is super interesting because I think Martin he liked the fact that his article, microservices, is the source of truth, really, or kind of the canonical definition. But he's a bit scared that people are just adopting microservices without actually knowing what the hell they're doing or why or anything. Just, that British bearded guy said so, let's go for it. So he created some follow-up articles on why and how of microservices. One of them is this one. It's called Microservice Prerequisites. And it tells you, the analogy is it's like a carnival or amusement park where to join some ride, you have to be as tall. So, you remove the children that are too small, it could potentially suffer some bad stuff happening from the ride itself. It's a great article, definitely worth reading. But I would summarize it here, or at least my interpretation of it is that there's three things he talks about. The first one is rapid provisioning. So you must have rapid provisioning to have a proper microservice architecture. What does that mean? That means that if to put a new service in production, I need to email 10 different people, 10 different people to get new machines, and maybe a new rack in the data center, and it takes 2 weeks, and I have to talk to 5 different departments, you probably will not have a good time doing microservices. There are ways around it. There are a lot of our friends working in the big enterprises do. You just order, in the beginning of the year, you order 100 billion machines and just keep using them over the year. I have seen this. But you should probably, if you don't have some way of having, provisioning machines or servers or computing units super quick, you probably should reconsider. The second one is basic monitoring. That means that, when you have one application, oftentimes you're careful with adding logs and adding alerts and nagios and whatever you use. That's cool. But when you talk about microservices are a weird word because kind of doesn't mean anything. But when somebody comes to me and says, I have a microservice architecture, the only thing in my head that I know is that this person has a lot of services. That's the only thing. Everything else is, sure, each person says different things. But if you have a lot of services, that means you have to monitor all these services and make sure they're working well. It's not just one box here that you can feel the pulse and see if it's working or not. So if you don't have any kind of basic monitoring across all these services, you might reconsider going for microservices. And the third one is rapid application deployment. So we talk about provisioning the machines. Okay, you got the machines, you have a full rack. What do you do with this rack? Well, how do I push my code to be working there? Depending on the organization, depending on what happens, there's various different ways of making code to go from your machine to production. I know that when I was working in Brazil, at a company I worked at, my deployment process was literally to burn a CD with the code, walk 2 kilometers downtown Rio, and turn it to the client, who then copied to the servers. So it's kind of a long deployment process. Sometimes it was raining, it rains a lot in Rio, it wasn't very nice. But that's kind of the situation. Obviously, this is an extreme, but if it takes a bit too long or it's too complicated for you to deploy your application, you might want to reconsider doing microservices. Okay, cool. All these, I agree with that. I think that makes sense. But it still gets me nervous. Still, there's something about this, like, it makes me feel uncomfortable. Nervous is not the right word. It's like, especially because this article, I think, was out, when was it? So it was last year. So we were already quite ahead in our microservices journey. I was like, shit, there's something that I'm not super comfortable with this. So to understand a little bit why I wasn't so comfortable with this, let's talk about how things kind of came to be at SoundCloud in this particular aspect. We have published a lot of blogs, presentations, as I said, and you may know a little bit about the SoundCloud story, but I'll try to summarize. SoundCloud moved microservices because of reasons. I mean, there's reasons. There's a link here. I try to write as much as possible on why and how we actually ended up going with microservices. I'm not going to go there today. But just assume that we did the right thing. Maybe we didn't. I don't know. But for the purpose of this talk, assume that, yes, we should have moved to microservices. There were good reasons. And then in abstracting like 100 million feet away, we moved from what also Martin called a sacrificial architecture, which was the original SoundCloud application, built on Ruby on Rails, MySQL database, Memcached, written by the two founders who cannot write software to save their lives, but somehow pull it off. And from this big blobby Rails application, we moved to microservices. Obviously, again, this is an abstraction, right? This arrow is quite fat right now, but it's not as fat as it should be to show how much actually went between A and B. But that's kind of in principle what we've done. We had a sacrificial architecture, we moved to microservices. But then, this is the story we talk about a lot in conferences, and SoundCloud is very proud of, but that's a bit that happened before. Before we made this jump from A to B, from the monolith to microservices, SoundCloud in 2011, when I first joined, was a bit like this. Who has seen this interface? I see there's some hardcore old school users here. When I joined SoundCloud, my ID was 5 million something, and everybody else had ID like 35. I was hiding my user ID at all times because I was so ashamed of it. But yes, this is what was called classic SoundCloud. Classic being a synonym for old stuff we don't want to touch anymore. This is backed by Rails. It has all this stuff from like Web 2.0, social links. You can see the interface sometimes doesn't work very well. There's an iconic waveform that made the company be super famous as a brand and all this kind of stuff. So we're in this situation. We had this application. We had this monolith. And we knew, we were observing the industry. We were hiring people who had experience in service-oriented architecture, even though it wasn't called necessarily microservices. We knew we were going to need to do this services thing. We didn't know if it was micro, mega, whatever it was. But then we sat down, and again, the company was 20 engineers maybe back then, so we could sit down and decide things as a group very easily. And we decided to prepare for the microservice explosion. It was like, okay, we know that we're going to have a lot of services. We need to be ready for when this happens. So a lot of the work we've done, a lot of work I'm going to talk about here, was started and sometimes even finished, for some value finished, before even have the first service running. Not something I would recommend, but it's probably a topic for a different talk. So let me try to map what happened as we were preparing to get our monolith split into services to the framework that Martin had laid out. First, let's talk about provisioning. Provisioning of machines, right? SoundCloud was born on Amazon in 2007, and eventually it migrated to its own data center. So now SoundCloud has one data center in Amsterdam. They do a lot of processing on Amazon. The storage is all on Amazon. But there's one, actually there's 2 data centers in Amsterdam. Prior to that, they had data centers in other locations as well, until they moved to Amsterdam, as lots of European companies do. It's actually super simple to get a machine on SoundCloud in terms of process. You send an email to somebody, somebody sends you an IP. But obviously, it is not easy to automate. I can't really get my continuous delivery pipeline, send an email to Bob, and Bob replies to that IP, and then I pass that IP. It's complicated. So we're like, okay, we have all this, and remember, that's 2011. Oh, yeah, 2011. So we have all these machines, what do we do? We looked at the industries, like what's available here? There wasn't a lot of open source stuff available. But there was one product that wasn't open source, has never been open source, that was super, super exciting, and that was Heroku. Who here has used Heroku? So Heroku, for those who haven't, is a platform as a service, runs on top of Amazon. And Heroku is like super, super simple deployment. They start focusing on Rails. Now they do everything, really, Java, whatever. And it's very well integrated with Git. So what you do is you get your code, you push to the servers. You say, hey, I want 5 instances of this running. And somehow, magically, it will run. It will be allocated to service. SoundCloud has a very good relationship with Heroku. We have lots of friends, and people have similar backgrounds. And Heroku has open sourced some of its stack from back in the day. So just as Heroku was what was super hot in terms of product, these kind of technologies and techniques were super hot back then. First one is DoZD. I always spend a lot of time when I give this talk explaining what's DoZD. But I've been through maybe 4 talks today, and all of them have mentioned Zookeeper one way or another. So I assume that you kind of know what Zookeeper is. Zookeeper is, imagine it's like a kind of consistent blob of hash map. That's a good description. That's a technical term. So DoZD is very similar to this, except it's a very confused Zookeeper that barely works. It loses message all the time. It has to be restarted. The journalist system is a pain. It's really bad. But it was back then, again, 2010, 2011, was pretty awesome. The second thing in there is Linux containers. So we're talking about containers now, Docker, and all this kind of stuff. Back in the day, there was no Docker. Actually, some people who were in this project left SoundCloud to work for Docker Inc. And we built we wanted to use containers, even though you had to do all the wiring yourself, like many people who don't use the Docker still do. Google does it, Facebook does it, Twitter does it without Docker. And then there's something that's super cool, actually. It's called 12factor.net. Who knows this website? Couple hands. If there's one thing in this talk that you should read about, is this. This is guidelines Heroku has published for applications to work on their own platform. Turns out that if you follow those guidelines, you have a potential of creating very easy to scale systems, because those guidelines are awesome even if you're not running on Heroku. Because we were pretty much copying the Heroku infrastructure, we were using that. But even if you're not, even anywhere close to Heroku, go take a read. I agree with some points more than others, but I like the fact that this is being proven by companies like Heroku, SoundCloud, Salesforce. A lot of people deploy applications this way. So go check it out. It's an actual website at 12factor.net. So what we ended up with, we got all these things together. We spent some time building stuff. And what we got out was something that was much better than anything else, seriously. And I'm very critical of this system, but back then, it was much better than anything else, open source, or that we could afford. Because we were big enough that, yes, you had a lot of money, but they also had a lot of servers. So it creates a problem for you. And it was amazing. I think it might still be open source on the SoundCloud GitHub repository. It's called Bazooka. But first, it was a massive investment. We had, 4 people working on it for 1 year, which for a startup with 20 people was insane. And we did have some problems. Remember, we were doing that as we were preparing for the services to come. Meanwhile, the teams were developing the services. When the services finally made it to production, we found some interesting issues with that. First, that we had containers, but we didn't have isolation. Containers is a very complicated topic, and I don't want to go too deep in that. But if you know a little bit, we did chroot, we didn't do C groups, which means there was no I couldn't say this process can only use 50% of CPU. This process can only use 10% of CPU. Every now and then, you'll be running two applications on the same machine. One application will be a super fast C++ classifier for spam, which means that would just pin down the CPU and starve everything else that was running on that machine. It doesn't really matter how many cores you have. There's only so many cores that, well, this thing actually takes out the cores. So it was super bad, and we had a lot of problems where we didn't even know what else was running on that machine, and the application would be misbehaving. It was somebody else's application that was using too much resources. Second problem was naive scheduling. We always thought that we're going to go for the simple approach when it comes to scheduling. So when I push an application to the cluster, it just gets deployed to whatever is available. There were some very, very simple heuristics. And then we were going to iterate on this and create a better scheduler. Turns out that we never had time to create a better scheduler. And this thing is still in production this day, a really, really naive scheduler that pretty much just pushes the application to the first available machine. If you combine these two things, what you have is a classic loud or noise-enabled problem that you used to have in Amazon. You still have in Amazon, but now it's much less than what it was back in the day. So if you remember what I said 2 slides ago, SoundCloud was born on Amazon. And the reason we left Amazon was because of the noise-enabled problem. We ended up creating the noise-enabled problem in our own data center. Not very smart. But, back then, it's like, oh my God, that's the best we can do. That's the best there is around, except by the Googles and the Facebooks of the world. But I think there was another problem that maybe was more interesting, which is all the tooling and all the platform was really made thinking that we were going to be using Node, Go, and Ruby. So there's this language or platforms are wildly different, but there's one thing they do very well. They have a small memory footprint. Each process takes only megabytes of memory. Node less so, but Go and Ruby, you can make it happen. And they have super quick startup time. So you run a program, it just starts running immediately. Eventually, SoundCloud has migrated to use first Clojure and JRuby, and now almost all of SoundCloud is Scala. So the main problem is that first, a JVM is kind of a monster, and whatever memory you have, it wants to take it. And also, the JVM has a slow startup, which actually is a good thing for server-side applications, because the reason it has a slow startup is it starts in a very naive, almost interpreted mode, and then keeps compiling itself and getting better and better over time. So it takes a while for the JVM to get better. But this all infrastructure we built was around the ability to first, that applications would not, well, each process would not use a lot of resources, so the contention, because we didn't have isolation, wouldn't be too big a deal. And also that we could move processes easily and just kill them and start new ones, which on the JVM is not exactly true, because each time you reset the process, you pay the price of bootstrapping it again. So that was a problem. But I think the worst problem we had was actually the fact that, meanwhile, we started working on V1 here. We deploy, what was it? We deploy V1 here. I'm a horrible engineer. This graph has no legends to it. And they started working on even the V2 of the application, the infrastructure we had here. But meanwhile, the industry kept getting better. Mesos was released, and Aurora on top of it, Docker, and Kubernetes. So all that investment we were making, actually, especially for a small startup with constraints, not necessarily in how much you could spend, but how many people we had available to work on these things. In the end of the day, if you look at when we released the platform to 100% of our services, if we had done absolutely nothing and just waited until here, let's just go to the beach for 3 years, we would end up in a much better situation. Obviously, it's hindsight. It's hard to know how we would know. There are techniques for kind of try to go about predicting these movements in the industry, but that's reality. And that was a big problem for us. So we tried to solve this problem. And the first attempt, when I first gave this talk, was very simple. We hired some people from Tumblr, the blogging platform. And at Tumblr, they developed something called Collins. Collins is a super simple inventory management system we would just tell Collins which machines we have, which we call the intake, which images to apply to each machine. SoundCloud is mostly Debian, pretty vanilla Debian. It would keep a warmed up pool of machines. We call this machine container host. So those, instead of, because to bootstrap a machine from nothing to what we call container host with the proper image and all that, it takes 10 minutes. So we would always keep kind of a farm of machines available. And we would push Docker containers to these machines from, well, less like a user, kind of a little sticky figure there, but from our deployment pipeline. That was, when I first presented this talk, which I think was February, this was what we had to do. And we knew that we had to write just a little bit of glue code to make it happen, just a little bit. Yeah, famous last words. So after having to pretty much re-implement a scheduler in Bash, which is something I do not recommend, we have decided that, this is insane. Let's stop. The main idea we had is that we had so much complexity. Let's just, scorch the earth, destroy everything we have, and then build a better house out of whatever is remaining. After this experience, like, you know what? Let's do something a bit more sane. So let's just have a machine intake process. Chef runs SoundCloud. And then put these machines in Kubernetes cluster or multiple Kubernetes cluster, and it's still the same process where we deploy Docker containers. So this is what SoundCloud's migrating to right now. As I left the company, there was a presentation on Kubernetes Con, KubeCon, whatever it's called, by SoundCloud people recently. I don't think there's a video available. I haven't seen the presentation, but this is the direction we are going at SoundCloud. It's very similar to a lot of other companies are doing. So second one, telemetry. Telemetry is a funny one. We hired, one thing that happened at SoundCloud in 2012, maybe, is that we hired a lot of people from Google. I don't know if I mean, for those of you who live and work in different countries in Europe, you may know that the easiest way to get an engineer to join to join a company in Berlin at least, is for you to find the Germans who want to go back home. So we had a lot of people coming from Google and Twitter and Facebook who wanted, I want to move back to Berlin. I love the place. I just don't have a job that I'm particularly fond of there. So as SoundCloud was growing and people were knowing about it, they started applying to SoundCloud, which is great, except the people who came from Google were appalled by the quality of the tools we had for monitoring. They're just like, I cannot believe you're able to run a website with this. I was like, And what was this? I'm sure a lot of people here have this set up as well, because it's super common. StatsD, which is this thing published by Etsy, aggregates metrics. StatsD sends data to Graphite. Graphite's a database. It's written in Python. Everybody kind of uses it. And it's very, very, very famous for running out of disk space at 3 a.m. It's great. Graphite pushes to Nagios, which is the alert system everybody loves to hate and hates to love. And then Nagios eventually, call PagerDuty if there's something going wrong. This is a very basic setup. Lots and lots and lots of companies still run with this, and it's okay for most use cases. Another piece here is New Relic, which SoundCloud have used until I think 2 months ago. They got rid of New Relic. The New Relic, if you use New Relic, there's an interesting problem there, which is they get really expensive as you grow. When they're small, they're super cheap. But as you keep growing, when you look at your bills, like I could hire 5 developers with this price. So that's one thing that happened at SoundCloud. The product's great, I really like it, but it's super expensive. Netflix had the same problem with App Dynamics, by the way. They had to go away from App Dynamics because it was super expensive for them. But Netflix scale, right? So as any good engineers, what we do, we build our own. And especially engineers coming from Google, to be honest. So there was, again, we looked around. There was nothing that we thought could provide any proper tooling around this. No open source project, no cheap enough vendor that could sell to us and we would be happy with. So these guys who have been, they are definitely domain experts in all this area. They sat down. SoundCloud has a 20% time off policy copied from Google. They spent a couple of weeks building a prototype. We decided to make an investment and go ahead with it. And eventually, a system called Prometheus was released. Who here has heard of Prometheus? People here? So Prometheus is open source. I think I'm going to talk a bit more about it later. But we built, it replaces the rest of the StatsD meets Graphite. It has its own dashboarding thing. It uses a different model. StatsD pushes data to the server. And one thing that we found is that these can actually destroy your NIC, your network card. You have to end up putting the telemetry data off-band, so in a different network card to not compete with your own traffic. There's a lot of really complicated things you can do. One of the things we've done was to create a fractal architecture, which a lot of people do as well. It's complicated like shit. It's just like, you can do it. I'm not saying you cannot scale that, but I don't want to be that. Anyway, so we ended up with Prometheus, and we replaced Nagios with Icinga. Icinga is Nagios you would show to your mother, but not you wouldn't get married to it. It's a better Nagios. If you hate Nagios as much as everybody else, just go check it out. And we kept PagerDuty. Awesome. I know of much larger companies in SoundCloud that still use PagerDuty. They're super good, even if you grow much more than a couple of developers or a couple of servers. So that's all good. We had all the investment, but once more, that wasn't broke, right? That wasn't where the problem was. When we finally made it to microservices, the problem was kind of, I'm trying to simplify here, but if you think of it like this. When we had one application and a problem happens, it's very easy to know what the problem is. It's in the one application you have, right? So you go look at it and, okay, I'll in. When you have a microservices architecture, or a service architecture for that matter, but again, the only thing that microservices means to me is that you have a lot of services. So when you have a lot of services, God knows where the problem is. So you're like, oh my God, this guy is erroring, but it could be this one, it could be that one, that one, that one. Oh, where is it? Where's the actual problem? And we had lots and lots of problems with the microservice architecture in this aspect. And we've done a couple of things to kind of ease the pain. I don't think, I wouldn't say that right now SoundCloud, as of 2 months ago, suffers with this problem anymore. And a couple of things we've done was, first, standardized dashboards. I remember that I got paged at like 3 a.m., went to my computer, look at my service. My service was like 500, super high, nothing weird. And it's like, what's going on? So it's like, I know my service talks to service B. So I pulled the dashboard for service B. I didn't want to page the person responsible for service B immediately, right? Maybe I could solve things myself. And I was like, okay, the graph looks the same. And I spent, I don't know, I was until 5 a.m. up until I realized that the other person's graph, even though it looked the same, like a dashboard like this is a Prometheus dashboard, and it had like same colors in one dashboard, another dashboard, it had a different time unit. It was measuring things in hours, I was measuring minutes. It was, like here there's a breakdown, 400, 200, 500, so this is all 200, so it's good. They had a completely different metric. I was comparing like apples and the Enterprise spaceship. It just like, it made no sense. And then one thing we've done, SoundCloud uses an open source software as well, part of the Prometheus family called PromDash, was to make sure that every single service is deployed with the same dashboard. You can have as many dashboards as you want. Maybe you want to measure different things. But there's a canonical dashboard that sits in, so in the internal SoundCloud network, PromDash / your service name. This is a real one from a service called API v2. You go PromDash / API v2. It's the dashboard for this specific service. So this works very well. Another thing that works very well is standardizing operations, making sure that our services, they have knobs that people know how to turn. This is actually from Twitter, it's not from SoundCloud, but the SoundCloud one looks very much like this. Every service at SoundCloud binds to an admin port, so it always binds to a port to receive traffic from the user and to return, and another port with a HTTP interface that receives admin commands, and you can curl them. So you have, for example, a command to shut down the instance. You have a command to enable log level trace. You have a command to do, what else? What do we have here? To profile the heap if you want to see how many clients are connected and all those kind of things. These you can all do through curl, and it makes it super easy to do these things. Second one is, I'll have to go a bit faster because I took a bit too long on the jokes. Second one is distributed tracing. Somebody has already mentioned Zipkin here today. Zipkin is a project that started at Twitter. SoundCloud is a co-committed to it now. It's called OpenZipkin, actually moved away from Twitter. I don't think there's anybody in Twitter working on it. There's people from Pivotal, I think, and people from SoundCloud. It traces all requests within your microservice architecture. So receive a request originally here from the user, and that spawns other requests here. Each one of them will be tagged in a way that you can see in an interface that here looks like shit, but actually it's very much like Firebug, the breakdown you have on browsers for JavaScript development. You can have a very similar experience with microservices. So let's move on to the third part, the last part, which is deployment. So when the cluster software we created was first published, or we actually first started using it, I gave a talk, I can't remember what it was, and I showed these screenshots, which is me pushing an application to live. So if you see the first one, I'm sorry if you can't read, but the slides will be online. The first one is just a git commit of some change. And then I do a git push Bazooka master. Bazooka was a remote git repository attached to my machine. And I would just push to that repository. And if you look here in these last lines, if you can potentially read it, it will say that there's some lines there that are not actually from Git, not from the vanilla Git you get pushing stuff from GitHub. It says, oh, you can see the logs here. I'm upgrading this, I'm doing that. And that's a build process that our clustering software, which is backed by Git, very much like Heroku, was performing. And then I would just say, scale this process. I had each application had a different of processes I could get to 10 servers or to 1 server, and it would just scale automatically to that. And then if I do a PS on the Bazooka, I can see that this process from this application, this Git revision is running on this IP on this port. So if I go to that port, I can actually access that, and it's super cool. And the tooling works very well. There was a couple of problems though. One of the big problems that to make this work, I had to push to Bazooka. Now let's imagine the developer lifecycle. I'm on my machine, I'm typing code, I'm like committing, good. Every time I push to GitHub, which is what SoundCloud uses for version control, it would then, Jenkins would get this code, would run unit tests, acceptance tests, integration tests, performance tests, all kind of tests, and would say, this artifact here that I built, this jar file in SoundCloud's case, this is definitely good to go. We should push it to production. And then immediately we would throw it away. Like that one artifact that we tested and we know works, we throw away. Because in a process like this, I have to manually push to the repository from my machine. And because it's based on my development credentials, I cannot even automate that without being a security risk. Oh, sorry. So what we ended up with is everybody wrote their own deployment script. We ended up with 7 different deployment scripts across the shop, which is not great. Recently, about 1 year ago, SoundCloud migrated to something a bit different, which I do recommend investigating, which is our deployments are based on a continuous deployment pipeline. This diagram is a bit old, shows Jenkins here, but actually SoundCloud migrated to go.cd, or CI, which is it's an open source system built by Thoughtworks. It may or may not be related to us hiring a lot of people from Thoughtworks, but that's a different thing. So what you do now is that you develop on your machine, you run make, which because we have code in Scala, we have code in, still code in Ruby and other platforms Go. So make is our build tool, who then calls SBT or whatever you actually happen to use. And in your machine, we run unit tests, integration tests. Okay, cool, everything works. We push it to Git, then Jenkins, then now go.ci. We run the tests again. Jenkins runs on well, whatever they use right now, runs on Amazon, so have elastic slaves. If there's 10 builds in the queue, they spin 10 different slaves for you to get. Runs the same tests again, some more tests, packages the Debian file, and then first it pushes into a Docker container and pushes to the Kubernetes cluster. Now, some of you who have used Docker are thinking, what the hell, why are you putting in a Debian container and then, in a Debian package, and then in a Docker container? Why don't you just create a Docker image? Because another deployment target for us was Amazon with no Docker, just deploying straight to Amazon. So that's one thing that we've done there. But the most interesting part of using containers in a microservice architecture is that eventually we were able to run, to let people spawn the mini SoundCloud. There's one thing that I haven't heard here today, which is a bit interesting. The biggest problem with microservices to me is how do you test this stuff? How do you, if I have 100 microservices and I want to test feature A, and feature A touches 50 microservices, do I have to spin 50 microservices? People say, I use stubs. So you're not really testing anything, right? You're testing the stubs, good, but not. With containers, we were able to simplify the process of spinning this mini SoundCloud a bit, much better even. A lot of it's based on Docker Compose. There's some scripts around it. But definitely, if you're looking at this, I would look at Docker Compose. But then back to Phil in the beginning of the presentation. Why was I so nervous? What was going on? What that article from Martin got me a bit like that feeling on your stomach, in your stomach. Well, I think the best way to summarize, and probably also the technical term, is that we screwed up. Like over this transition, when we were preparing ourselves for the big services explosion, we over-engineered everything, and pretty much everything we over-engineered was wrong the moment the first service hits production. So my main recommendation here is, if you're going for these things, if you're going for microservices, before you even think about, even using something like Kubernetes, just make sure that you understand that there's many different ways, some of them super simple, to fulfill these three things. We didn't even know there was no such list when we first started, but intuitively we knew that we had to go about these things, but we completely over-engineered the problem, and the solution we end up with, it didn't survive the first test. So do not do that. But then I was, over these microservices conferences and different things, I befriended Adrian Cockcroft, who was the architect for Netflix when Netflix moved to a services-oriented architecture. And I was talking to Adrian around this when he was visiting us at SoundCloud, and over beers, like, oh yeah, man, we screwed up this, and this, and this. And then he looked, and if you've seen Adrian, it's like this tall, very British guy. He looks like, what the hell? Do you think we got it right the first time at Netflix? Do you think it's like, mate, not only we iterated on this like crazy for like 10 years, but also there's a lot of stuff that Netflix doesn't publish, doesn't make open source, because they're not super proud of. I'm like, hey, that does make me feel better. It still kind of sucks, but yeah, sure. So this is also a takeaway. Like, you will screw up. Everybody screws up. And that's okay. Just make sure that you have short enough iteration cycles that you can move yourself, steer your development out of a problem you might find. So last slide, 3 things that you probably want to consider if you're going for microservices as well. First one, Prometheus. It's a great piece of software. It's all open source, massive community. Everybody's building tooling around this. Super recommended. This second, what I mentioned before, the 12-factor app. Go read the website. Even if you don't agree with it, what I tell you is like try it for a bit before you have an opinion, because some stuff here won't work for you, but try it first. Iterate, see if it works, see where it breaks. Do not try to customize things from the get-go. Try it first. Some smart enough people have thought about this model. Again, may not apply to you, but give it a shot. The second one, which I actually don't mention in this presentation much, is a framework called Finagle. If you're on the JVM, it's a framework built by Twitter that I think it's one of the big reasons for SoundCloud to move to microservices, which a fairly successful approach, was relying on the IP that Twitter has built over time. Finagle, the way I describe it, it's a library. It's written in Scala, but you can use from any JVM language. And it has 10 years of fail whale in it. So there's stuff in Finagle that like, God, why would anybody need that? Client-side load balancing, that sounds stupid. And then you get another 10 million users, and your load balancer breaks. It's like, oh, that's why they need that. Do not use it everything from the get-go. Start super simple. Services, filters, super simple. But you can rest assured that most of the problems you will face, if you face them, if you're successful, and I hope you are successful, there will be some kind of answer in the library itself. And the community is super cool. Pinterest, Foursquare, SoundCloud, lots and lots of really big companies use it very successfully, including people who don't use Scala, just JVM. So I'm a little bit over time, but do we have time for questions?
1 minute. Can you manage 1 minute?
Yep, let's do that.
I have one question. You mentioned in the long run, you moved to Scala and Clojure. And what's the benefit of it, and how does it get along with the microservices?
Yep. So the question was, I mentioned we moved to Scala and Clojure, and the question is, what's the benefits, especially in a microservice context? Is that right? Yeah. So we first moved to, we knew we have to move away from Rails. We tried to make Rails work. We first moved to Clojure, mostly because I've been doing Lisp for like 10 years, and I really like Lisps. At some point, we thought that it was much easier if we had used Scala or Java 8, that I think was just fresh, than Clojure, especially in the people we could hire. Europe is a great place to hire Scala developers. It's insane. There's so many smart people everywhere. So we decided to move to either Java or Scala. We started with Java 8. But the moment we adopted Finagle, and we're like, okay, if this is going to be part of our infrastructure, we decided to, maybe we should move everything we have actually to Scala as well. Turns out that my experience so far is that as much as people complain, you can get somebody who's very experienced and has only done JavaScript in their life to know enough Scala to write a service to go live in less than 2 months. They can actually go there. There's all discipline you have to do and you have to apply and some tooling. But the SoundCloud experience is that it can happen. My personal take now is that I don't really care. I just want a model real close to Google's model, where they have, 4 or 5 different languages. I actually would like to have 2 languages, maybe, in my platform. It drives you crazy when you have to build tooling for all multiple different things. At DigitalOcean now, we have Ruby, Perl, Go, Java, and I think Clojure somewhere. And just the tooling built for all this is insane. Good. Okay, thanks, everybody. I'll be around.